thing we're going to go through is we're going to try and populate as much of this little Excel file here, and all I've got is basically the category, the identifier, and any part numbers and manufacturers information that we can fill in, stock codes, things like that. This Excel file is almost going to be like our reference document. As we start to build this up, we can cross-reference things and we can look in that and build up all the information that we need to know about this board as we go forward. And that's probably going to be developed at the same time that we're going to be working on the schematic here as well. I think we'll start with going through the integrated circuits and move on to that one. This first one is easy. IC1, which is this UART device here. Turn that round there. I'm going to go IC1. And the part code for that is IM6402 IPL. That's that one. And we'll have a little look up on that. Screen. See if we can find out who made that one. Can't quite remember. I do know who it was. Honest. 6402. Let's see what comes up. Intercell by the looks of that. It's a digital data sheet. Quite the logo that I'm looking for, that one. But yeah, they're printed intercell. Not sure about that. It's a different logo as well. Now, actually, it looks like that very much looks like the Harris logo. Actually, so although intercell did do that, I think that's Harris. Right, let's see if we can get that data sheet. Harris. Right. Right, okay, over there. Because of the logo, I'm going to stick Harris in there. And package is a Jordan 9. I suspect that's about 40. See what's going on here. Crypto CS guy, cool stuff. Thanks for joining the chat. It's nice to see you in there. Might be a slight delay while I look at these messages because we've got all sorts of different views going on. Let's get back on that view there. 1991 week 11 date code on this one. In fact, all of this stuff is late 80s. That's 1989. Anybody who doesn't know, date code on these down there, 8/9 for the year, 1989, week 20. Okay, so this is all late 80s stuff, about 30, 35, 36 years old. I think the vast majority, we've got a 90 there. 1990. Vast majority are all around this age. In fact, actually, that Jordan line package is probably the most recent one. Let's give a ping count on here. Thank you very much for the likes there, everybody. Do appreciate that. I am going to be running this over more than one live. So if you're not subscribed already, do subscribe to make sure you don't miss on the updates as we progress. 1, 2, 3, 4, 6, 7, 11, 12, 13, 14, 15, 16, 17, 18, 20. Yeah. So dual in line, 40 pins. And I shall update that on here. 40. Whoop, 40. There we go. Stock code and supplier. Yeah, we'll not do that. Now, we are going to have to build this model up because it's currently not in Proteus. You can't see that. We are going to have to build this up as a device, because that specific device isn't in Proteus. Let's move on. IC2, we need to find that, which it looks to be this one here. So MC14585, and move on to this screen. IC2. That's that one. Probably we have got a notes section, but that's just off the screen over on this side. We probably will put more information as we build this up. Now if I go over to Proteus and we look in our parts library, and we're going to put in there 4585. Okay, and that's a CMOS 4000 series. Okay, and a 4-bit magnitude comparator. Now that should match up if we go on the internet and see if we can get a data sheet for that particular device. MC 14585. See what we get. Right, I've got a data sheet, and I'll bring that across. Let me just bring that across for you to see. Hopefully you can see that. Yeah, okay, that's on screen. The old Motorola stuff often had a number 1 in front of the part code. Okay, when you're in Proteus, if you see some of this Motorola stuff or MC1 something, okay, you should be able to just look up that part of it there, 4585, and that should bring you up a match in the Proteus software. Okay, and what we're going to start to do is we're going to start to build up, get rid of that one now. We're going to start to build up our parts list within Proteus. If I add that to the parts bin, like that, we can drop that on. We're going to edit the properties, and we're going to call that IC2, and then we're building up as we go along. And that's what we want really. We want to be building all this information. Minimize this so I can see what's on the screen. Might be a little bit small for you to see because we've got both of these side by side. Not too much I can do about that until we're at a point where we can start working full screen. Moving on to IC3. See what we've got for IC and whereabouts that's hiding. IC7, IC5, IC3 is here, and again, Motorola part, date code 1990, and that's going to be a 4017. Here, 4017. Decade counter, and we're going to drop that on and update the identifier to IC3. Keep everything sync, and MC 140 7 BCL. We know that this one is Motorola, and I think these are Jordan 960. So you can see that. Just do that. See. Three. 1, 2, 3, 4, So we're going to update that. Still 16. Okay, moving on to IC4. Where's IC4 hiding? IC2, IC7. Shout up if you can see it before me. Gone. IC8. IC9, IC5, 3. Where are you? IC6. IC5, IC3. What's that one? That's 8. Gotta be that one, surely. Surely. IC4, there it is, down at the bottom. Yep, we've got you. Okay. IC4. I4. CD54. 4060. 4060. F. Again, it looks like Harris looking at that logo. Harris. And let's do the counts. In so Dill 16. Now, on Proteus, what I'm going to look for is 4060, okay? And when we see, for example, this part number here, 54, okay? That's just a military equivalent, so higher temperature range. Okay, and instead of the 5-4, I'm going to go for the 7-4. Okay, that's loaded. We're going to go for that one. 14-stage binary counter with oscillator. Okay, so chances are that's something to do with time. We'll add that, and we're going to drop that in. Get the identifier. I see. Okay, moving on. IC5 is what we're looking for next. Back onto this view. IC5. There we go. Fairly straightforward. Find. And it is a 14013. MC 14013. Spot it a mile off. Motorola. And 1, 2, 3, 4, 5, 6, 7. So that's a 14-pin package. .4013 is the part number that we're going to look up. That 4013. Dual type D. And there's two parts to this. So there's two devices actually in one package. And name them IC5. That IC5. Okay, that's that one. Save our work as we're progressing through. Next up, IC6, 7, 5, 3, 8, 9. I see 6 down there. Again, another Motorola. 4011. MC14011. Manufacturer, Motorola. Okay. 1, 2, 3, 4, 5, 6, 7. So DIL 14 on that one. And part. Got it in the library already. 4011. Quad 2 input NAND. And this will be multitude of gates. Got them on. And we are currently on IC6. Dated. IC6B. IC6C and IC6D. Excellent. It's that one. IC7 is here. Another Motorola device. Device here. 1, 2, 3, 4, 5, 6, 7 pins again. Motorola. P. And in Proteus, 4025 is what we're going to look for. Matches we've got. Yeah. 333 input NOR gate. Have them on schematic. Over. Seven. Properties. 7. And finally, IC7C. Yup. Next up is the IC8. Let's have a look at that. IC8 I think was over to this side somewhere. IC8 is this device here. One there, another Motorola. 1, 2, 3, 4, 5, 6, 7 pins. MC14584. MC14584 BCL. Another Motorola. Still 14, I think is what I counted. That part in. 4, 5. 4. Another magnitude comparator. Four. 14584. 4584. There we go. Right, that is a hex Schmidt trigger. 4 and I've quite a few now. 1, 2, 3, 4, 5, 6. Drag them. Yeah. I see 8. These. I see 8. Right, and that's changed. Got those. C. I see D. E, and the final one is F. Okay, brilliant. That's that done. Now we want to move on to IC9. IC8, IC9 is there. Another Motorola 14073. MC14073. PCL. Motorola. Package count on that one is 1, 2, 3, 4, 5, 6, 7. 1989 date code. So DIL 14. 14. What else we got? 4073. Got this one. CMOS 333 input AND gate. Gate should be in that one. It's over. And we're on IC9. Edit properties IC9. IC9. And final check on that one. IC9. IC10. Which I think is this little one down here. It is that. MC1558. MC1558. So, Motorola again. And that's an 8-pin package. Still 8. And that's a much earlier date code. 1983. So a lot of those left over on the shelf. Right, let's see. 2158. I think that could be. What's going off? Right. There we go. Right, let's see. One. I think that's an op amp, a dual op amp. I think. Yeah, dual operational amplifier. There's that device. Screen. Okay, so MC1558. Summing amplifier, voltage follower, active filtering, function generator, low power Okay. Some kind of op amp on that one. Close that. I think that's all of the integrated circuits covered. We have got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 devices there. Okay. There's 2 connectors. We've got socket B there. This socket connects through to the other board. Okay, there's 2 PCBs. And socket A is this one here. Might be able to focus because I'd have to move the microscope up. But that's the connector for socket A. And I think what we'll try and do, we probably now need to start to look to track some of this together. And the plan that I've got is we're going to choose one device and we're going to start mapping out from there. Okay. And the way we're going to do that, we're going to be looking at the circuit board itself. We can use a torch to shine through and we'll see the traces. And we can start to build up the schematic as we progress. I'm going to check something else out. Just bear with me a short while. Switch over on another screen. That one. Let's see what else we've got on here. Just bear with me. Thought I had some kind of dashboard where I could see your chats easier, but it doesn't have time. No, I don't have. Somewhere else, just stand by. Please bear with me. There will be a short interlude. Nip off and get yourself a drink. I've just had a cup of tea brought to me. Let's have a look. Yeah, okay, right. We're back on. Yeah, that's right then. How's that? I should be able to see the chat clearer now that I've found that window. I'm going to remove this from the back shell. There we go. Still got a wire attaching it here. And looking into it, this device here, which is the UART, we're going to leave that until later on. The reason being is that we don't have this device listed in Proteus. So we're going to have to make that as it is. I am 6402. Don't think that's in there, it's not. I think what we're going to do, we're going to leave that one till last. We'll start off with one of these other ones. I think the one that was interesting was the one with the oscillator. I think was this IC2, I believe. IC3, IC2. That one there. Pull up a data sheet for that one. MC145 data sheet for that. Not that one. Yeah. MC14585. No, that was a magnitude comparator. It wasn't that one. It wasn't 4017 either, I don't think. MC14585 4017. 117. Decade counter. Decade counter. That was IC3. Got this one, yeah. Let's see what's going on. (14017). 14017 is IC3, which on the circuit board is over this far side here. Okay. Okay. High speed operation and spike free outputs. Now, we have got a number of outputs over on this side here. Q5, Q1, Q0, Q2, Q6, Q7, Q3, and this is our 0 volts connection. VSS, that's labelled. We've got VDD over up here, a reset pin there, a clock pin. That clock pin is probably going to be coming via a buffer maybe from this crystal circuitry here. It does look as if it goes along there, look. Okay. Reset pin here, pin 15 reset. Now it doesn't look comes out of this right hand side. Some light under here. Adjustment there, and try and get you better focus by shifting that up. Lights on there. Right, that should be a bit better for you all. Pin 15 is what we're investigating then. Pin 15 on IC3. Right, what I'll do now, I'll go full screen with that so you'll get a better view. IC3 is this one here. We're going to bring that off onto its own sheet. Assign new sheet. And system. Set sheet sizes. We'll go for A3 on that one. And zoom to the entire sheet. Let's copy across this IC3. Clipboard. Switch over onto our sheet. Paste from clipboard. Okay. This is the one that we're interested in. Reset pin is this pin 15 here. We want to see where that goes. Okay. So pin 15 IC3. Which is this one here. We can't see any track coming out of this side, and I suspect it's going to go underneath, which we can see just there, look. If you look at that, you can see the trace actually disappears under that part and under the IC. So we'll switch that over. No clue here as to where that's going, but I would think it's going to go along here, connect into this via here, straight down here, along here to this pin here. That pin there is this pin of IC8. So 1, 2, 3, 4, 5, 6, 7, 8. Pin 8 of IC8. Check that. Travels up here, along here, to there, and across here. I'm just going to check this side just to make sure that wire isn't used and comes across from here. That is clear, look. Down here, you can see the light shining through there. On that side, you can see the trace disappears off there. So pin 8 of IC8. Let's take a look and see what that is. Pin 8 of IC8. 8. Right, we're going to put that to the clipboard and bring that across. Join that up. That's our first connection made. Enjoy a cup of tea. Get you all having a relaxing evening. Right, drag that out a little bit. You're probably going to see where this goes. It's pin 9 of that same device. Okay. Nine is going to be next to it. Pin 9 is up here. And interestingly, there's a silk screen marking on there, look. A, B, C, D, E. So certainly this device is key. The fact that they've added some extra markings onto this silk screen, I think that's definitely to do with that. We're looking for pin 9, which is over on this right hand side. There's nothing there, look. I'm looking for a trace in between the pad and the body of the IC, and there's nothing there. I'm going to flip that over. We were here. Pin 8, and this one is pin 9. This pin 9 going along this trace here, there, along there, zigzagging about a bit, along to here. There we go. It goes down to there, which is our big 40-pin UART package. Right then. That's going to be this bottom pin down here. Not the last one, the next one. Check on that. 1, 2, which it is. That should be pin 19, I believe. I'll just double check that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Right. Pin 19 of IC1. because we haven't got IC1 on there yet, what I'm going to do, I'm going to put a label down. Now, I'm going to label that net IC1 underscore 19. And that's just to tell me at this stage, that's heading off to IC1 pin 19. So I know in future, when we add IC1 in and we've created a package for it, I'm going to map that out. Okay. The next pin of interest is probably going to be pin 14. Pin 14, pin 13 of IC3. IC3. Eyes are back on you. We are looking at pin 14. 16, 15, 14. 14 is coming down here, along here, and across that capacitor box. I suspect it's coming down to this link here. I think. Down. Now, would it make sense for it to then disappear into IC4 in 1, 2, 3, 4. Pin 4 of IC4. It looks like we've got some kind of configuration jumper switch there. 1, 2, 3, 4 of IC4. Let's see what those are. Pin 4 of IC4. 1, 2, 3, 4. Yeah, potentially that could be the case. Well be the case, couldn't it? But what I'd like to do, see if we can get a meter on there. Okay, let me just grab a meter and we'll see if we can just continuity that out just to satisfy ourselves that that is the case. Like that. Hopefully you can pick that up on the microphone. We were interested in 4. Yeah. In 1, 2, 3, 4. Right, so it definitely runs to there. And we wanted to know whether that then runs to here. And I'm happy that that does. Right. That bit tested out. Run that back under there. Better focus is back on again. Right then. Let's cut this one out and we'll take that across to the other sheet. This one clipboard. And it was pin 4 went to 14. Flat out. The aim is just to get this out on as a quickly at the moment, and we'll tidy it up later on. This is an enable pin, so we'll look at pin 13 of IC3 next. Pin 16, 15, 14, 13 comes down here. It does head off underneath, look. I can see a trace heading up and off. Probably this one here. It's going to come down here, across here. Down to there. That splits off again. I would say across there and up here, probably over to that side. I'm gonna see if we can bust that out. That one there. 1, 2, 4, 2, 3, 4. 4. There. 2. It's got conformal coating on, so it's quite difficult to get through and make a good contact. But yeah, we're definitely on to pins 16, 15, 14, 13, 12. 9, 10, 11, 12. Pin 12 of IC4. Pin 12 of IC4 master reset. Now that's interesting. Drop that trace in. That is interesting. Because that also goes off somewhere else, as we saw. I think it heads off under here. I'd probably say we go round about the houses, maybe. Here and back now. Even be there along here. Tricky one here. That pin there. Bust that out. No joy on that one. Take a look off camera on that one. I'll show you that view. So you've got something to look at rather than a base of a microscope. Torch and then have a proper look. Oh, in fact, actually, oh. I think it goes to 2 on that side. Yeah, let's continuity that out for you. think it actually comes to pin 2 here. Pin 1, pin 2. Get that on the screen at the same time. There we go. Pin 2 of IC8. Pin 2 of IC8. Philip Reed, what's the board off? Sorry for the delay in replying to that comment, Philip. The board is from I think it's going to be from a Sea King helicopter. It's a data transfer device by Racal Avionics. And the thumbnail does show the whole board in its entirety. And as we progress with this, I'll start sticking some more pictures in. But at the moment, we're unfortunately on this microscope, so we're a bit zoomed in on that. But yeah, military helicopter, Sea King, and it's here in the UK. It was either Royal Navy or Royal Air Force. Some of the Royal Air Force ones were the big yellow budgies. Might know them by the nickname. Search and rescue as well. Right, what did I say? IC8 pin 2, wasn't it? IC8 pin 2. So, IC8 pin 2 is that one. I'm going to cut that and bring that across. Clipboard. Design onto boot 2. Paste that. This is going to be our drive. That's okay. Wondering why you reverse engineering it. We're actually trying. We're going to try. There's a view of the circuit board. We're going to try and get it up and running. Now, I think there probably is going to be a fault on it because marked on the case, I suspect that's US, unserviceable, faulty. That's what I suspect. So I think somewhere probably is going to be some kind of issue with it. I mean, if not, it is 35 odd years old. But the idea is we're going to reverse engineer it, obtain a schematic, and then we'll try and do something daft like make a little USB storage device or something along those lines. Probably more for entertainment, really, purposes, just to teach people about how these things work, a bit more about electronics and the logic gates and things like that. That's the aim behind it. Yes, right. On to here then. So this reset circuitry is just driven by this. We can join that one up now. We know that branches off to IC4 and IC3. Pin 1 on there goes off somewhere else. So it's probably a good idea to have a look at that. IC8 pin 1, which is going to be this pin here. That one there. Don't know whether we've got another connection on there. No, we'll clear that side lot. So what I'm looking for is down there. I'm looking to see if there's any shadow of a trace going under there. Nice one. I'm currently doing an old amp. Yeah, there's some nice stuff out. I mean, I think the older stuff has got a lot of kudos. You know, this newer stuff, I don't know. It's not quite the same, but you know, it's not quite the same, that's for sure. It'd be nice to get it working again. 35 odd years old, and I'm sure the same with you. You're working on an old amplifier, you know, to bring that back into life, the sound, the audio quality that you just can't get from the old stuff. In my opinion. I do like the sound of the older stuff. This trace comes out to here. And let's just have a look and make sure there's nothing under there. that one. Somewhere around about here. Pin 1. Pin 1 there. But it does cross there. Which I think it does. It does head off. Trace out there. We've got C8. Now, we didn't put any capacitors yet on our schematic. But that just looks like they're all the same. You can see one up here, 103. I suspect they're probably all going to be the same. Let's see if we can identify. Are you sure? Are you sure that the RS line goes to pin 2? The track goes around that pin. Look, the RS line goes to pin 2. This one here, I think you're talking about, Philip. Pin 2. I think we did continuity that one out. Let's have a look. I think this is the one you're talking about, which is here. I did have to take this one off. So I see 8, pin 2. You can see the track heads underneath, and I think it just comes down here, down under the chip, and out this side, and it joins us back up to there, and that's where we get this branch off. One onto this chip here, and the other one heading up under that and up to that one there. I think that's the one. We did bust that out, but we will bust that out again to make sure. There. And we want to be on 2 on. Thought it was going to call me a liar then. And not beep. Yeah, that's it. That's it. We've got it. We've got it. It is actually quite difficult to continuity these boards because of this conformal coating that they've got on. I mean, it's a lovely finish, but it is very difficult to bust out. Now then, we were seeing where line 1 went. You want that view there. And it's to do with this capacitor here. Let's move my keyboard. Right, there's nothing just in that side there. Now I've got a capacitor. And we want to have a look at that. Worried about where that side's going at this moment in time. Let's have a better look under here. Somewhere around about here. This is our pin 1 identifier. We come out here, we go to here, we go to this joint here, which I'd probably say that's a hole for a different size capacitor maybe. That capacitor heads up, and in fact actually we've got the same here. It just gives them options so that they could put a smaller device on, or probably even one of these, get one of them in there. Yeah, that's all that is. So that side we're not too worried about. That side there, we're not too bothered about that. That just comes up to here. That goes on to power or ground by the looks of that. It's this way here that we want to go. We want to follow this out here. This is pin 1, 2, 3, 4. So it's between pins 3 and 4 right next to it. We've also got another one which goes out to here. Let's see what this is on this. 1, 2, 3. Between 3 and 4, it was this resistor here. 2, 7, 0. So that's a resistor. 2, 7, 3 zeros orange. So 2, 7 for the purple, orange, 27k. That resistor there. So we've got a capacitor. Then a 27k. Get those on actually. That is R4. And I'll see which side the capacitor, whether that's going down to ground or up to power. Res. N. Capacitor. Standard. Device. That we don't know. I'm thinking it's going down. And the resistor. Put that up here. We know that that's R4. R4. We also know the value is 27k. Capacitor we're not sure of yet, but we can give it the identifier. Where are we? C8. C8, C8, C8. And put that in. We haven't read the value yet, but let's pop that in and see if we're about right. Now we do need to see where that goes. We want to know whether that was connected to one of the bus lines. It's either going to be onto a power supply or it's going to be onto our 0 volt rail. So I think if we go on there. Board out again. See if we can get on here. Through this conformal coating. Right, got one side. There we go. I'm going to say ground. In 1, 2, 3, 4, 5, 6, 7, 8. That's good enough for me. That is good enough for me. That over. That onto there. Join those up. And join that up. That's done that one out. Can see where the other side of this resistor goes to. See where that goes to next. Resistor here. 4. No connections on the top. Switcheroony. Do progress on. I think it's that one there. It does go off elsewhere. 1, 2, 3, between 3 and 4. That was the connector there. That was the resistor there, sorry. That progressed onto here. The other end of that resistor goes to here. Now, interestingly, is that going to be a ground as well? No. Right, have we? No, we haven't. We haven't by the looks of it. Okay. Corrected that. We're going to look now where that goes. That comes up here to there. Which is going to be this resistor here. Confusion over the identifiers there. I thought we're happy as this one. Come down onto here. Okay. Hard to see. Nine. Now, can we find another R5 or another R9? Turn that off. R2. R15. R9. We've already got an R9. So I think we'll go for R5. That one. Now, it would make sense seeing as one previously before it was R4. So R4 to R5. Yeah. That's a good enough plan for me. Back onto here. Let's drop another resistor on. Edit that. I'm going to call that R5. Unless we find anything wrong later on. And colour-wise, I think Philip's already on it there. Yellow, which is 4. We've got purple, which is 7. Orange, 3 zeros, 47k. That's spot on there, Philip. Yeah, definitely. We can change this then. 47k. And the identifier, yeah, I don't know. I think I'm going to go R5. But can we find... When you'd said R12... R12 is here. Where are we? R12 is there, but I'm not sure whether R12 actually comes down to this here. With this mark in here, R13. So R12, R13. I'm going to say that that identifier is for this component here. And I think the R5 is hiding under here. I think we're a bit short on space. I'm going to stick with R5 for that one, and R12, I think definitely down this one. Didn't see that, yeah, I couldn't see it at first. I actually had to take that off and have a look at it with a torch rather than through this microscope. It is well hidden under there, that's for sure. That is for sure. And what we want to know now is where the other side of this R5 goes. We're back onto here. This we think is R5, and we have got quite a thick trace there. I think we're going to be looking at either some kind of power or some kind of ground. But we've got some Zener diodes there, potentially. Be in that circuit. Let's see if we can find anything going on. Five. That. We'll see if we can match to the obvious. No. There. So this might actually be an external signal. Haven't broken through that insulation yet. So we've definitely got a match going along here. That's a match for sure. Okay, so that isn't connected to that. It does come round onto that one on its own. And I think that resistor. Does that ion connected? Those diodes there, which just trace. Go anywhere. Ah, okay. I've got this here. Which loops round, and I think that's that 8-pin dual op amp. 1, 2, 3, 4, 5, 6, 7, 8. Pin 8 of that dual op amp. goes to there. I think that's the shadow that we can see. Yeah, let's continuity that out. An 8. Well, that makes a bit more sense. That resistor does also go off to another resistor. Ten. My other sheet. I'll not add it. I forget to add that one. I think I did. Well, I never. Right. I remember talking about it. Okay. Let's add that then. Five, 5, 8. Let's see what we've got. Equation amplifier 1558. There we go. Yeah, I've already got it in the library. 1558. So we label that to be IC10. C10. IC10. And it's a pin 8. Pin 8 is the power. Now this has got split power, but we don't know whether that is plus or minus, or whether just reference to 0. So that's a power in essentially. Don't know quite where that goes to, but what we'll do temporarily drop that in for now. I think what we can also do, follow that out. See if that goes to one of these pins. I'll explain the trace. Sure. There. Go down this connector. On the journey. Still power coming in for that one. In. This is 1, 2, 3. Pin 6 of socket A. Which doesn't necessarily help because we don't know what pin 6 of socket A, where that goes to. Pin 6 of socket A. Pin 6. We haven't got 17 pin. See what else we've got. Have we got anything ready made? That's Molex. Quite what we're looking for. Do for now. Yeah, it looks like that's something else that we're going to have to make the device. Yeah, there's nothing that quite happy enough there. What we'll do, we'll label that up again. Do the same as what I've done here. Bring that out. Cross. Bring that to an end. And drop a label on it. I'm going to call that socket A. Pin 6. Socket A6 for that one. That's probably the end of that trace, because when we look at the other resistor, which is this one here, the problem we've got is that's just another power feed off. Right then. What other methods of inquiry we can progress with? I think we've mapped this part out. We've got all of the input side of that control. What I think we're interested now is this. I would expect some kind of timing circuitry, capacitor resistor network, and I would say this is going to cascade out of here, and on Q5 we're going to get switch of signal, which is then going to clock this. So we're probably interested in what these outputs are doing with this carry line here. The carry line might not actually be used. Probably that's an easy one to confirm. IC3 pin 12. We'll have a look at that. IC3 pin 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's that one there near this capacitor. And There's nothing going under the IC. 9, 10, 11, 12. 9, 10, 11, 12. There's nothing there. So we just need to have a look on the underside. Let's see, 3. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And there's nothing on that underside either. So that's a no connection, that one then. Now, for now, what I'm going to do is I am just going to drop that on there, so we definitely know that goes to no connection. Just to make sure that we're not testing anything and then retesting it again, just in case we think, oh, that's an open line, we need to look at that. This shows us that we've definitely investigated that line. We're interested in all of these others now, Q0 to Q9, and we're interested to see if any of these or all of them are used. Now, should be able to have a quick visual on that. So pin 1, 2, 1, 2, 3, 4 onwards. So I see 3. Light on. One, nothing there. 2, nothing there. 3, nothing there. 4. Pin 4 heads off. 5, 6, 7. 1, 2, 3, 4, 5. 6 heads off. 7 doesn't head off. 4 and 6, we've definitely got traces heading out. 6, 7, 8. And 9, 9, 10, 11. 9, 10. 10 we have. And 11 we haven't. So 4, 6, and 10. 4, 6, and 10. Right then. Probably start with the lower number first. So 4. We'll take a look and see where that's going to head off to. I see 3, pin 4. That's an easy one to map out. 1, 2, 3, 4. And that goes straight to this one here. I see 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I see 5, pin 11. And that heads off elsewhere. I see 5, pin 11. Right. I see 5, pin 11 comes from this pin here. IC5, pin 11. We're going to cut that and we're going to bring that over to this one here. Paste from clipboard. Delete that we've added on. Pin 11. Zoom in. Pin 11. Join that up. That does go off elsewhere. Just so we're aware of that. I'm going to pop as a junction dot on there. And I'm just going to bring that out just to show us that we've got something else to look at on that one. Right. Let me just check a few other things out here. That's all the comments on there then. And let's have a look. We want to be on that one. Bring that back on again. Back onto there, right. Now, we are interested where that heads off to. This top part was easy to find. It disappears up under there. Can't quite see. The bit that I'm looking at is under there. You can see that trace heading this way. It could well be that one there. Well be. So I think that could even then go on here and under. We'll have to get continuity on that one. Jump that back down just so it's in better focus. IC3 pin 4. Bust this one out. Let's see. That onto there. We know it heads this way. In fact, drop onto that. And we'll just check that we have got a good connection on there, which we have. Scope charge. Yeah, I have got a bench scope, Philip. But I think it is this trace here. Potentially it comes along here. It's not going to make it easy, this one. Let's just make sure there's not anything obvious. What are we looking for? 1, 2, 3, 4. 1, 2, 3, 4 from pin 16. And that chip there. Fourth one from pin 16. 16, 15, 14, 13. No, there's definitely nothing under that side. We suspect it heads off under here. Yeah, I think that looks like that's going to come all the way across, I think. I think it's going to head out here logically, potentially down here, potentially even to here, look. Yeah, let's have a look at that. Let's go with our gut instinct on this one. Our gut instinct. In there. We think it's going to come down here. I'm going to go for that one. Down there. I meant microscope on charge. Ah, yeah. Yeah, this is batteries running low. I'm going to need to do something, that's for sure. Now that's thwarted us then. Check this one out. Yeah, I'm not sure how long I've got on the battery on this. I'm not even sure how long I've been streaming, to be quite honest. It is the first time that I've used this microscope for a stream. Got nothing on there, look. Disappointing. I'm not sure what I'm going to do for it when we come to. Might try and break off in minutes. USB-C lead. Get this back on charge. 100 minutes. Okay, I mean that's not bad charge for this little microscope, to be fair to it. Got no match on there. This one is proving very elusive. I thought it was this one. Let's see what's any clues under here? That one there. 100 minutes, crikey. Ah. Okay. Okay. That would be about right. Down to that one there. Which is this pin here. Let's bust that out. Yeah. Okay. IC6. Pin 8. IC6 pin 8. I see 6 pin 8. Right then. I see 6. Pin 8. Cross to here. What's that? Bit of room just to add our circuitry into there. 6.8. That across there. Right, that's mapped that out. And we should probably make sure that there is no other connection. Pin 8. No, there isn't. Which I'm happy about. Now, can I find, we have got a red battery warning up here. Can I find a little USB-C lead? I'm gonna go and see if I can get this on charge. Yeah, just bear with me for a short while. In fact, I'm going to try and find a cable and I'm going to have a quick toilet stop. Let's see if I can find a cable. Bear with me for a couple of minutes. Right, I have found a cable. Whether it's of a suitable length to get some charging, I don't know, but let's try. Right, that's that plugged in. Charging mode. Okay. Well, we've got it on charge. Carry on for a bit longer. But, yeah, it's not the best because there's now a cable draped over the desk. So I'll have to try and sort that out for next time. Where were we? Where were we? Shall we see what pin 9 goes to if I see 6? Might make a good idea. Let's have a look at that. Just need to be careful. Right then. Right then. Okay. Pin 9. 9 of IC6. Longer now, so you can put a cable in the way. Something we can fix for next time. Something we can fix for next time. 9. Which is 1, 2, 3, 4, 5, 6, 7, 8. Pin 9 heads off underneath. And we're looking at that trace there that heads out under. Potentially could come up here. Let's test that theory first. Pin 9. Conformal coating is very good. Get on there, but I can't be sure that I've got a good connection. Let's see where that goes. Ah, it's easy to trace out if it's that one. Just gonna come up here, 1, 2, 3rd, pin up. Onto there. That's a negative. So it's not that. Right. Get a visual on it with a torch. Okay. Looks I could just go straight across this pin on this side. Got a straight through look. Test that for continuity. Yeah, we're happy with that. 1, 2, 3, 4, 5, 6. Pin 6 of IC6. Pin 6. Didn't realise I was still on the schematic there. Yeah, sorry Philip, you are 100% correct to chastise me there. I didn't realise. Just so you don't think I'm telling fibs. Amazing, isn't it? The meter turns off. Right. Pin 6. Start on there. There we go. Okay, so just go straight across, and I do apologise for anybody that didn't see that. Just ends up going from that side under there. We can see it popping out this side here. That, and back onto the schematic. Yeah, so sorry about that. I do apologise. And thanks for saying we can't see. Pin 6 of IC6. So let's bring that across. 6 of IC6 is this one here. That, and we'll drop that across to the other sheet. Now, these here then, the first thing that tells me is that I'm expecting this to go off somewhere else as well. Okay, something else happening here. Looking for a missing track on that then, without any shadow of a doubt. Back onto here, we're definitely looking for a missing track. And this one here, IC6. Let's take a look down this side, and there we go. I think that's the one we're looking for. Down to there, look. That matches up on this side to there. That goes to here. We'll see if that makes sense once we find out what that pin is. 1, 2, 3, 4, 5. Pin 5. Pin 5, IC9. While we're here, see if that heads off anywhere else. Look. 1, 2, 3, 4, 5 of IC9. 5. IC9. IC9. Pin 5. That's another input. Okay. Bring that across. 5 of IC9. That's interesting. We still haven't found where that source is coming from. Let's have a look on the underside of the board. Pin 1, 2, 3, 4, pin 5. Excellent. We've found another trace. Coming along here, up here, along here to this one here. Pin 1. So that's pin 2. Pin 2 of whatever this is. Pin 2 of IC5. Pin 2 of IC5. So is the other half of that gate. 2. Okay, yeah, that would make sense. In fact, that's not good there because that's going to struggle for connection to that. So them out that way a little bit. Five. That's our connection for that one. And we would expect these inputs to be driven from an output, and that's going to satisfy that requirement there. Definitely need to do a tidy up or something. Now we'll carry on mapping. I'm interested to see if the Q output is driven as well, or whether that just goes to a no connection. So I think we'll test that one out next. IC5 pin 1. Nothing on that side. Let's see, that's unconnected. Just for a bit of better focus. IC5, and let's have a look on the... Yeah, we have got something. IC5 pin 1. That heads off, so that does drive other circuitry. It looks like it splits off down to here as well. Let's see where that goes. So pin 1 of IC5 goes to that pin there. Doesn't look to go anywhere else. Both sides. That is IC7. 2, 3, 4, 5, 6, 7, 8. Pin 8, IC7. Pin 8, IC7. IC7. Okay, some more logic circuitry. Pin 8, IC7. 8IC7, that's that connection made. Now it did also go off elsewhere, as we saw. Carries on down here, down to here, halfway in between there, so it's probably going to disappear off somewhere. 1, 2, 2 and 3 on this side. One, 2 and 3. That's where it comes through. It heads off potentially down and under here, potentially under there as well. So we can get a better view of that. Right, I think we're going to have to continuity that one. One of IC5. IC5. That. I'm not sure. Yeah, we got. Zoom out anymore. Now I think that comes down to here. I think it disappears under here. I'm not sure where it goes there. Potentially it comes up onto that resistance through there. Maybe. That. Try and take a better look at what's going on under here, but we'll just check these. The chances are it's going to come along here, up here, and onto there. Potentially pin 1, pin 2 of IC6. Pin 2 of IC6. Let's just have a look and see what else is going on there. Nothing underneath. Can see it here. Just hiding under there. And next to check. Trace coming out there. I'm happy that that's going to pin 2 IC6. Let's see what that is on the schematic. That's 2 of IC6. And I think what we'll do as we progress mapping out this schematic, we're going to find out a bit more of the functionality, and we can split these off onto their own sheets. Just make this schematic a bit easier to read, but for a first pass, we're happy with that. Right. Be interesting to see where pin 1 goes, because we are in that area now. Pin 1 of IC6. IC6. Pin 1 of IC6. Pin 566. Right. Now, you can see pin 1 of IC6, we've got a diagonal down onto there, potential to come out here. Okay, flip it and see. We've also got a trace underneath. 1, 2, 3, 4, 5. Pin 5 also feeds pin 5. See what pin 5 is. IC6 pin 5. Right, okay. We've already got that on here. Pin 5. That also heads off elsewhere. 5, and let's check the other side of that. One, 2, 3, 4, 5. We're clear around that pad. Don't progress anywhere else. Oh. Except I think we do. Potentially come out of there. I think following this trace here, look. Coming along here. This is from pin 1. That via there. Have a look at that. That should be under this component here. I'm expecting those two pads to line up as well. Let's have a look at that. There's the via that we're looking for. That's heading off directly under there, making it easy. This one, that's for sure. Potentially it could join this, we don't quite know, or it could come out. Let's have a look. So, only the first in. That's going to be from the bottom of this one here. Now, doesn't make it easy because potentially that via could go straight into both of those traces. It goes off to here, potentially to here. So yeah, this is quite a key one, this one. I'm going to visual this. See what I can see off the scope, just because it's easier for me to see. Okay, it only goes off to the right. Yeah. Sorry about that. Visualed it. Doesn't head off to the left, it heads off to the right. Okay, I'm going to have a look now to see if that does go straight under that resistor. Where we go. Potentially be here. Potentially that one. Visually that as well. Let's see. Well, looks as though heads off down here, then it goes up, comes out here, round here, up here. I think we come out to this pin here, so we're going to continuity that. Let's see if that's the case. So IC5. See if we get a continuity on it. Potentially a no. Good. Test. Yeah. Trying to do this to not block your view. Right. Definitely not that, that's for sure. Oh. Right, I'm going to go on this side of this pin. I think we've got a false one. I think that connects through to pin 2, doesn't it? I think we've already found pin 2 goes to IC51, which is correct. Yeah, we've got no match on that one. Let me take another look at that. Quite a tricky one, this. We think it comes out this side. I think that's connected. Yeah. So a lot. Back to basics. Back there. That heads up to here. In between. Bottom pin and the next one up. That. You can see it heads out to the right. Don't know what happens under here. Let's have another visual on that. Go round about. Just go to in there. I think we've got it. We was checking 205 C6. Side. That yeah, I'm happy with that. That's pin 1, 2, 3, 4, 5, 6. Pin 6 of IC8. That took some finding. 6 of IC8. Blimey. Right. Pin 6 of IC8. That's an output, so I would expect that to have been connected. 6 of IC8. Yeah, okay. Yeah, I'm happy with that as an outcome. Let's just see where we're at. There. 5, obviously. That's what's then driving this onward circuitry. Right. In 5. Let's see where that's 5 of IC8. IC8. In 1, 2, 3, 4, 5. Okay. Here. And underneath. Along there. It appears under here. One, two, three goes in between those second or third pins. Potentially here. Back through to here. Might have a match there maybe. Let's have a test around here. Four, 5, and potentially up here somewhere. Yeah, I'm happy with that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Pin 12 of IC5. Interesting. Okay. 12 of IC5, which is down here. Yeah, we're happy with that. We've still got the logic following there. From this Q output. And that one's from that one. That matches up. We've tidied up them. Could potentially have a look and see what's going off with these two other inputs. Perhaps we should see if IC5 pin 13, the Q output, goes to anything. Whether we can eliminate that. IC5. Pin 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, 12, 13. Nothing under there. Let's check the underside. Pin 1, 14, 13. We do have a connection. Goes down to that via there. That via there. Potentially disappears under here. Might come out this side onto there. We can continuity that one out, and it does proceed off as well. Let's check that out. There, for a visual of that. Potentially, I found it. Visually, it looks as if into that pin there. Sure we are just on that pin. Which we are, look. So 1, 2, 3, 4. Pin 4 of IC9. Pin 4 of IC9. 13 of IC9. I've already that. Of IC9 done. Go. Oh, it's here. 13 goes to pin 4 of IC9. While we're at it then, we might as well see where pin 3 goes of that, and that will complete the input side of that gate. Pin 3 of IC9. IC9. I suspect it will be difficult to see this one. Looks T C9 3 enough connection. Yeah, we've got a connection from 1 to 3, 14, 13. 3 to pin 13. IC9, pin 13. IC9, pin 13. We know that that must also be feeding somewhere else. Yeah. This is tied. This is pin 1. 14, pin 13. We know this is tied to the VCC rail. Back onto the sheet. Forward back. And we can now look at this pin 6 output. Let's have a look at that. IC9 pin 6. 1, 2, 3, 4, 5, 6 in there. And on that side. Six is here. Goes to that via there. Via there, which is going to be down towards the bottom. Bottom of IC5. Potentially could be this. See if we can get a visual on that as to which way it goes. Right, I think traced it. It's actually this via here. I think it's going to come across this pin here. Let's see if we can get this one right. Oh, now we might not. Tricky one, this one. Tricky one to get it on this side here. Right. B. Can't see the other side, but try and get you on this side here. Joy. I do suspect it's that one. Right, we might have some technical difficulties. Whether we stand by with me, whether we're still streaming or not. Streaming still. I think we're still on. Still on. Bear with me while I check this out. It's just told me we're not streaming. Don't know whether we are, whether we aren't. We are. Yeah, it does say. We'll try and get this this connected on. Trace out this line. See where we're at then. We'll investigate further then. I think we're close with this one. Third pin there. You might be able to see this. There is no continuity on that one. Very strange. Down here to that wire there. This is going to be the upper wire. The upper wire of the two potentially goes all the way through there, but let's have a look. Anywhere else. Now we have got that. Way down to be able to think. There either. Right. We'll pause on that. Somebody has said that the stream has gone down. I haven't seen any comments for a while, so I'm going to bring this one to a close. And if you can still hear me, you should see me going live, and we'll bring you back with part 2. Thanks for everybody that's joined. Thanks a lot for your comments, Philip, and everybody else that's joined. Thank you very much as well. See you soon.